In this video, I'm going to discuss the effects of changing the value of a, b, and c on graph of quadratic functions. What are the effects of changing the value of a to the graph of quadratic function? The value of a determines the shape of the graph. When a greater than 0, the graph looks like smiling face, whereas when a less than 0, the graph looks like sad face. Besides that, for the graph of quadratic function, the smaller the value of a, the wider the curved shape of the graph and vice versa. Let us look at this graph. The value of a getting smaller. When a less than 0, the value of a getting bigger. The graph look like this. To know further, let us look at diagram 1. Fs equals 6x squared and Gs equals 2x squared. So the value of a is positive, so the graph looks like smiling face. And we look at the value of a of Fs is 6. And the value of a of function Gs is 2. The value of a of function Gs is less than the value of a of function Fs. The curved shape of the graph of function Gs is wider than the curved shape of the graph of function Fs. Now we look at second diagram. The value of a is less than 0. So we ignore the negative. We look at the number of here. A is, so we will find that the smaller of the value of a, here 2 is smaller than 3, the wider the curved shape of the graph. Now we look at this diagram. The curved shape of graph A is wider than the curved shape of graph B and C. Means that the value of A for graph A is smaller than graph B and C. For the graph A, the possible function is Fs equals 1 over 5 x squared. For graph B, here A is 1 and this one A is 10. So for graph B, the value of A is smaller than value of A of graph C. So graph B is Fs equals x squared and graph C, the function is Fs equals 10x squared. Okay, now we try to answer this question. For graph P, the curved shape is wider, so the value of A is smaller. So which one is the smallest number? Here is 1. A is 1 over 3 and A is 15. So I will choose this one. 1 over 3 is the smallest value for A. For graph Q, the answer is Fs equals negative s squared. Graph R, nearest to the y-axis, means the value of A is biggest. So 15 here. So graph R, the function is Fs equals negative 15x squared. After we learn the effect of changing the value of A to the graph of function, now we are going to learn the effects of changing the value of B to the graph of function. The value of P determines the position of axis of symmetry. When B greater than 0, the axis of symmetry lies on the left of y-axis. Whereas when P less than 0, the axis of symmetry lies on the right of the y-axis. When P equals 0, the axis of symmetry is y-axis. For the maximum graph, you will find that it is opposite of the minimum graph. When P greater than 0, the axis of symmetry is on the right of the y-axis. When P less than 0, the axis of symmetry is at the left of the y-axis. When P equals 0, the axis symmetry is the y-axis. To know further, let us look at this graph. When P is greater than 0, the axis of symmetry lies on the left of the y-axis. Whereas when P equals negative, the axis of symmetry on the right of y-axis. Whereas for the maximum graph, when P greater than 0, the axis of symmetry lies on the right side of the y-axis. When P less than 0, the axis of symmetry lies on the left of the y-axis. Now let us try this question. We look at the graph J. The axis of symmetry lies on the left of y-axis. Here is the axis of symmetry. Okay, so the value of P is less than 0. So means it's negative. So here is the value of P. The value of P is before S. So here negative 4. So the function for the graph J is fs equals negative s squared minus 4s minus 5. Now we look at the K. The axis of symmetry is y-axis, for means B equals 0. So for this function, fs equals negative s squared minus 5, B equals 0. And for graph R, the axis of symmetry lies on the right of the y-axis. Okay, so B is greater than 0. So now B is greater than 0. Here is positive 4. So the function for graph R is fs equals negative s squared plus 4s minus 5. Now we look at the last part, the effect of changing the value of c to the graph of quadratic function. The value of c determines the position of y-intercept. So if c equals 5 means y-intercept is 5. We look at here. Okay, c, the value of c getting smaller, so the graph go downward. Now we answer the question. For graph A, what is the value of C? The value of C equals 2. So the answer for graph A is fs equals s squared plus 2. Look at the graph B. The y-intercept is 6. For the graph B, the function is fs equals s squared plus 6. For graph C, the y-intercept is 10. So the function for graph C is fs equals s squared plus 10. Example 3. The diagram shows two graphs of quadratic function y equals fs and y equals gs, drawn on the same axis. State the range of the value of p. Explain your answer. As we learned before, the curved shape of function gs is wider than curved shape of function fs. Means the value of a of graph of function gs is smaller than the value of a of graph of function fs. So p is less than 3. And because this is minimum graph, so a is greater than 0. So the range is p less than 3 and greater than 0. Since the curve of the graph gs is wider, thus p less than 3. For the graph with the shape U-shape, p is greater than 0. Thus, p is greater than 0 and less than 3. Thanks for watching. If you liked this video, make sure to subscribe for more.